Morning everyone and welcome to today's webinar. If you've missed any of our series which have been running since 2020, you can view them all on demand right here on our YouTube channel or on our Learning Hub at www.proctorgroup.com. You can also now register for our online members area where you can access product information libraries, personalised CPD certification and our free online U-value and condensation risk calculators. As always, you can also request product samples, arrange follow-up meetings to discuss the specifics of your project, or book one of our expanding range of REBA-assessed CPDs covering a range of topics. This can all be done either face-to-face with our team of experts across the UK or online. For our webinar today, we're taking a detailed look at the hygrothermal implications of thermal insulation upgrades on a solid, hard-to-treat wall. We've discussed aspects of upgrading hard-to-treat walls before, but with increased energy costs driving more emphasis on upgrading housing stock and many solutions on the market, now seemed like a good time to look in depth at how thermal insulation performance and vapour and air permeability affect these type of walls. Begin by recapping the background information around solid walls and hard-to-treat properties, as this is important, before looking at the means used to assess performance and the influence of various factors. The specific physical properties of the materials used in upgrade work can have a significant effect on the durability of the end result, and also on the long-term quality of the indoor environment. In upgrading existing structures, it's important to ensure we are not simply swapping a current problem for a new one. We'll consider these various factors and influences in little more detail than usual, before moving on to our regular Q&A session. Of roughly 27 million homes in the UK today, it's estimated that around 7.8 million, 28%, are of some form of solid wall construction. This is made up a mix of various thicknesses of brickwork right through to thick solid stone. Many walls are, for various reasons, also considered hard to treat, in that there is no simple and straightforward path to improve the hygrothermal performance of the wall. In a cavity wall or timber frame wall, there are typically large voids present, and simply filling these with an appropriate insulation material can facilitate a useful upgrade. It's not quite that simple, of course, and problems can still arise with such works, but compared to a solid wall, it's a relatively easy undertaking. In a solid wall, the only way to reduce the heat loss is to add thickness to the wall, either internally or externally. If space is limited, or if a large number of services or decorative features must be relocated or retained, internal systems can be less than ideal. Similarly, shared ownership blocks, limited distances to boundaries, or roof configurations can rule out external systems. Whilst this doesn't mean upgrading such walls is impossible, it does require more careful consideration than rolling out a cavity fill programme, meaning a lot of such properties are still awaiting upgrade work. A 2021 study conducted by the Leeds Sustainability Institute at Leeds Beckett University was commissioned by the Department for Business, Energy and Industrial Strategy in order to understand and quantify the benefits and risks associated with the use of thin internal wall insulation systems in solid wall refurbishment applications. The survey determined that up to 95% of homes had some form of obstacle that would require repositioning or addressing if insulation were applied to the external walls. Irregularities in walls, or walls that were not built level or straight, add further complications, as uneven plaster often must be removed, or levelling layers or battens applied. Such remediation may add additional depth to the finished wall system over and above the thickness of the insulation. The surveys also identified that in almost all cases, remedial works will be needed prior to any wall insulation being installed. For example, damp was observed in 9 out of 10 homes. A quarter of walls were already damaged. 13% of walls were not flat, posing issues for rigid board solutions, and 1 in 10 homes had no ventilation. Additionally, half of all walls already had plasterboard installed, which would need to be removed before any retrofit could take place. Once such work is undertaken, though, the reduced heating requirements can reduce greenhouse gas emissions associated with the property by 5 to 10%. Making an important contribution as part of a holistic package of upgrade measures. These additional measures could include upgrading heating systems, double or triple glazing, and even MVHR systems. Whilst it might be tempting to omit the insulation in favour of some of these other measures, the fabric-first approach of achieving good thermal insulation and low air leakage in turn makes sure that other measures can work effectively. It's also important to remember that cold spots internally caused by poor insulation and thermal bridges can lead to damp and mold growth internally, which has a significant detrimental effect on occupant health. So, addressing these uninsulated solid walls is important not only to reduce greenhouse gas emissions, but also to reduce fuel poverty and improve quality of life. The other important consideration with solid walls is managing the hygrothermal performance to ensure that condensation risk is minimised and the flow of moisture in and out of masonry is managed effectively. How we do that is dependent on a great many factors, and there are specific methods and guidance on how to ensure this is done properly. Primarily, this guidance is given in the Code of Practice BS 5250, which covers most aspects of moisture management in buildings. We've discussed BS 5250 before in our webinars, but today we're going to concentrate on the parts relating to solid masonry walls, insulated internally. Guidance on this is given in section 11.3.1.4 of BS 5250-2021. As was identified in the Leeds Sustainability Institute study, many solid masonry walls have various types of defects, and identifying and remediating these issues is therefore a critical step in the design process. This section of BS 5250 begins by identifying some of these areas and providing a checklist for pre-installation assessment and issues to consider during the works. Principally, the pre-installation guidance is concerned with ensuring the weather protection and drainage provisions, such as coping, pointing, guttering, and flashings are in suitable condition and working as intended. Secondly, the condition of beam and joist should be assessed, particularly where they meet the external walls, and the fabric of the walls should be inspected for damp. These inspections will reveal moisture issues that may be related to condensation or to ingress of ground moisture. It's also important to ensure any ventilation openings, such as subfloor voids, are clear and functional to consider services and fittings. These inspections will identify any moisture risks that are present because of the existing fabric and its condition, and the next BS 5250 checklist covers measures to consider to address these risks. While some of these, such as repairing weather protection and drainage, are obvious, some others, such as considering how the insulation can be placed to reduce cold bridging and associated risk of condensation at joist ends and windows, may be less so. Whilst it might seem that these thermal bridges are pretty insignificant in the overall picture of heat loss, if we model the heat flows in these areas, a different picture emerges. It's true to some extent that the overall increase in heat loss associated with these bridges is minimal compared to windows, for example. But if insulation is applied to the rest of the structure and these areas are left uninsulated, the change in heat flow patterns actually means that these areas end up colder than they were before insulation was applied. This can mean that the risk of warm, moisture-laden air collecting in these areas and condense becomes higher, leading to an elevated risk of condensation and corresponding mold growth. So, we can see how this holistic and structured approach to identifying and remediating moisture risk can be beneficial. And this structured approach is further built on in the PAS 2035 guidance document, which introduces the concept of inherent technical risk associated with combinations of retrofit work. This matrix shows these interactions and the relative associated risks. We have a webinar dedicated to this available on our YouTube channel and Learning Hub, so if you'd like more detail on PAS 2035 in this approach, you can review that on demand. For now, we'll keep to BS 5250 and consider the two categories it breaks moisture risks into: ADT, or As Designed Theoretical, and ABIS, As Built in Service. ADT issues are typically design stage considerations, while ABIS relate to more installation, management, and quality control. Both, however, are equally important. Let's first consider the ADT issues identified and how they can be quantified. BS 5250-2021 lists the following: surface condensation and mold growth, interstitial condensation, driving rain, moisture from the ground. These four issues all relate to how the moisture content of materials in the solid wall are managed, and we can assess this using dynamic numerical modelling. BS 5250 recommends this for solid walls in preference to a simpler steady-state model that is usually sufficient for other types of construction. The method for this is given in BS EN 15026-2023, Hygrothermal Performance of Building Components and Building Elements, Assessment of Moisture Transfer by Numerical Simulation. This method models the flows of heat and moisture into and out of the walls from both inside and outside. This allows us to see how the wall fabric absorbs, stores, and releases moisture, a process which is driven by heat, either from the sun externally or from the building's heating internally. In an uninsulated wall, moisture in the form of both condensation from internal moisture sources and from driving rain externally will enter the masonry of the wall and increase its moisture content. This moisture must then be dried out before it causes either mold growth or freeze-thaw damage to the masonry. The sun on the outside can drive moisture back into the building, drying out inwardly, or the building heating can dry it out outwardly. For an existing uninsulated building in the UK, typically most of the moisture movement will be from inside to outside, as we have a climate in which heating internal spaces is more common than cooling them. This can require a lot of energy though, as it needs the building to be heated sufficiently to dry out all the moisture from all sources, both internal and external. If moisture loads are high, for example from drying washing inside, or the building is not adequately heated due to ineffective heating systems or fuel poverty, then mold growth can result. Reducing air leakage, for example, by draft stripping doors and windows or replacing them with newer sealed units, can make this worse by reducing the pathways for moisture to escape by air movement. Similarly, if insulation is added, this balance can be further disrupted. This disruption can occur in two principal ways. Firstly, adding insulation internally will cut off the wall fabric from the heat source internally, reducing the drying out effect driven by the heating. Secondly, depending on the insulation used, the added vapour resistance internally might end up restricting the inward drying effect in summer. Taken together, adding the wrong spec of insulation to a solid wall, while certainly reducing the heating costs, can increase the moisture content in the base wall to an unacceptable level, leading to mold growth and damage. The BSEN 15026 dynamic model lets us look at the variations in moisture content and relative humidity across the entire construction, showing not only the effects of internal moisture, but also the weather and inward drying. This analysis can also be run across extended time periods, and if required, account for predicted future climate variations. This allows a reasonably accurate long-term picture of the hygrothermal performance to be established, which helps to ensure the overall robustness of whatever solution is proposed. Problems which are identified, typically around excessive moisture content at the internal surface of the masonry, can be resolved on paper at this stage, far more easily than if they emerge on site after 5, 10 or more years. We can see the importance of balancing the effects of heating, drying and moisture vapour diffusion in solid walls, but it's also important to address air leakage. Adding mechanical ventilation with heat recovery to existing properties is a complex undertaking, especially if internal space is limited. If such a system is used, maximising its effectiveness by minimising air leakage is important. If we fitted an MVHR system without reducing the air leakage substantially, the infiltration of cold air will render the heat recovery ineffective, resulting in more heat input being required. So, adding in an air barrier to the wall is beneficial to ensure we have a reasonable degree of control over the air leakage rate. Whilst older walls aren't necessarily as bad regards air leakage, without the consistent performance and a control dedicated air barrier provides, it's not possible to rely on hitting specific air leakage design targets. We supply two air barrier systems ideally suited to solid wall applications, both of which take a different approach to managing moisture risks. Wraptite, a self-adhered vapour-permeable air barrier, does not restrict the flow or moisture vapour through the construction, allowing the wall to dry out internally or externally. It also allows any construction moisture or damp within timbers to dry out once the building is heated, so can be used virtually anywhere in the building. This allows a continuous airtight layer to be established in the most convenient place, away from services and where penetrations can be minimised. The membrane can be sealed onto timber joists and floors without trapping moisture, greatly simplifying details and speeding up installation whilst ensuring low air leakage. Of course, it's still important to ensure the thermal and vapour transmission properties of insulation layers used within the airtight envelope are suitable to balance the flow of moisture, but allowing the airtight layer to function independently of this is an important advantage. The other air barrier option, Protec Adapt, takes a very different approach. This membrane is fitted internally in the same place as a conventional vapour control layer membrane, but the Adapt membrane varies its vapour resistance in response to environmental conditions. When humidity is high, the membrane acts as a vapour control layer, restricting the passage of moisture into the fabric just as a conventional air and vapour control membrane would. Where Protec Adapt behaves differently is when humidity reduces. Under these conditions, wherein a conventional AVCL would trap moisture in the base wall and limit inward drying, Protec Adapt becomes more permeable, allowing moisture vapour to flow back into the building and drying out the substrates. This variation in physical properties helps ensure the moisture accumulation in the solid masonry remain within an acceptable range, while still allowing the thermal performance of the element to be upgraded. With Wraptite, though, the properties of surrounding materials must be carefully considered to ensure an optimal result, and the dynamic modelling again provides a useful tool to assess the performance of various options to suit the project-specific construction and environmental conditions. As well as the theoretical risk factors and solutions that can be applied at the design stage, the as-built in situ risk factors are also important to address. The main concern in this area is to ensure that the construction process itself or any installation quality issues do not contribute to elevating the moisture load in the existing building fabric. To this end, it is recommended during the building process to protect areas of masonry that would not normally be exposed to the weather, and to ensure moisture contents are as close to normal in surface levels as possible prior to application of plaster coats or installation of internal fittings. Preventing the unplanned movement of moisture across cavities, for example, if cavities become obstructed by excess mortar snods or other debris, is also important. Likewise, any cracks, missing areas of mortar, uneven or damaged brickwork, or gaps and cracks around openings and penetrations such as pipes should be addressed. This is particularly important for new pipe or service penetrations that are being added, as any holes and gaps must be properly sealed to prevent not just the ingress of moisture, but also the unplanned movement of air. It's important to ensure that assessing and, if necessary, remediating these issues are factored into the project planning as an integral part of the build process. Any retrofitting and upgrade works should aim to leave the existing parts of the structure in a fundamentally better condition than they were at the outset, not to simply cover over existing defects in a new skin. The last factor introduced here is the condition and protection of embedded timbers in the masonry, specifically the ends of floor and roof joists. These are vulnerable to moisture uptake from a range of sources, which if not addressed can elevate the moisture content of the timber and lead to rot and decay. Capillary moisture from the ground, rain penetration and condensation can all cause moisture issues in these areas, and as with the base wall fabric, vapour-impermeable insulation and vapour control membranes can make these issues worse if not correctly specified. Particular concern in these areas is that the timber penetrates the insulation envelope, causing a cold bridge. This means that the ends of the timber element will sit at a temperature below that of the living spaces, so moisture vapour can readily condense and be absorbed by the timber. Once the project is complete, these areas are more or less inaccessible, making inspection and future repairs problematic. Again, using a vapour-permeable solution such as Wraptite can limit the potential for moisture to be trapped, and adding a layer of vapour-permeable space-therm aerogel insulation can reduce the temperature drop if it's possible to apply to the entire end of the timber. Space-therm aerogel has a particularly high level of thermal resistance per thickness, but is also vapour-permeable and hydrophobic. This means that it is not adversely affected by damp or moisture and will not restrict the free movement of moisture vapour or the drying out of the timber. This combination of properties makes it a good choice to use in problematic areas to reduce thermal bridging where space is limited. We can also supply Wraptherm, a combined self-adhesive airtight membrane with aerogel insulation, providing a simple one-step solution to cold bridging and air leakage. This approach can also be applied to areas such as window reveals, floor zones, or other areas where optimizing the relationship between heat flow and moisture movement can be awkward. While solid walls rarely lend themselves to a one-size-fits-all solution, taking a well-structured and holistic approach based on the guidance given in BS 5250 can lead to a far better quality solution. By reducing or eliminating the scope for problems to arise during the project, the overall cost and timescale can be reduced. Similarly, anticipating and designing out problems that may not become apparent for many years. We'll now move on to our Q&A session.
Good morning, everyone, and thank you so much for joining us for our live Q&A session. I hope you all enjoyed today's presentation. Lots of interesting and relevant information in there, as always. Now, for anyone who's joining us for the first time today, we're all here to answer any questions that you may have about today's presentation. So please drop any questions into the YouTube chat feed, or alternatively, you can send us a direct message through any of the social media platforms. We're on @ProctorGroup, or you can email them over to webinar@proctorgroup.com. Now, if you have a specific project that you would like to discuss with us in a bit more detail, or if you do have to leave before we get finished, but do still want to ask something, don't worry, just get in touch, leave some contact details, and we will get back to you. Similarly, if there are any samples that you would like to see or literature regarding any of the products that we discussed today, again, just get in touch and we can organise that for you. Now, if you have registered today, you will get a follow-up email from us that will have a replay link in there where you can rewatch the whole of this morning's broadcast. You can also watch back any of our previous webinars, and we have been running these since 2020 now. And these can be accessed either from the members area on our website or through our YouTube channel. Now, there is a huge amount of resources available on our members area, so do sign up and have a look around. Please, if you can, also subscribe to our YouTube channel and give us a thumbs up and leave some feedback as well. That really would be appreciated. Quick date now for your diary. Our next webinar, which will take place on Friday, the 24th of November at the usual time of 10 AM. The topics that we will be discussing and special guests will be released shortly, so do keep an eye on the website and our social media platforms for news on that, and get yourselves registered to join us back again then. Okay, let's move on now to our Q&A session, and let me introduce you to our panel for today. All familiar faces for you this morning. Let's start off with our Technical Director, Ian Fairrington. Good morning, Ian.
Morning, Carol. Morning, everyone.
Good morning. Next up, we have Head of Business Development, Will Jones. Good morning, Will.
Good morning, Carol. Good morning, everyone.
Good morning. Then we have our Head of Facades, James Brackenley Johnston. Good morning, James.
Good morning, Carol. Good morning, everyone.
And balancing up the beauty with the beasts, we have this morning our Senior Technical Advisor, Pamela Howitt. Good morning.
Morning, Carol. The envelope's in the post. Morning, everyone.
Perfect. Everyone all accounted for and sounding great. Now, I can see a good amount of questions coming in already, which is fantastic. Do keep them coming in, and as always, just bear with us all as we're collating them all in from different places. Okay, Ian, can I start off with you, please? Let's just start with the ones coming in live on YouTube. This one from Peter Stanton, who says, does plasterboard always need to be removed if you're willing to sacrifice loss of wall space and it is in good condition?
Yeah, thanks for that one, Peter. You're right. As long as you're happy to lose the space, then you can keep the plasterboard on if it's in sound condition. And probably more important is what's actually behind the plasterboard. So if you're sure that the existing wall is of sound construction and there's no dampness there, then you can leave the plasterboard on. Indeed, that's what I've done in the wall behind us. There's existing plasterboard, and we've insulated on the inside of that because I knew the wall was sound behind it and there was no dampness coming in. So as long as there's no dampness there, then you don't need to take off the plasterboard, but we would advise that you make sure that the wall is sound behind it.
Perfect, thanks, Ian. James, can I come to you with this one? This is still on YouTube from Joseph Masterton. This is a good one to sort of start things going. What is the best initial plan before starting my refurbishment?
So before you start a refurbishment is understanding obviously what your plan is, so the extent or scope of the refurb that you want to carry out, involving engaging enlisting a qualified designer or architect to assist with all the lovely nuances of refurb, so from the design, from material choice through to building control, depending upon, again, the scope of works that you're doing. So if there are new build elements integrated into that refurbishment, understanding the existing substrates is absolutely paramount. So not just sort of what you can see from the inside or from the outside, the complete through wall system, both floor and the external building envelope. Understanding the moisture retention within that facade system as well, understanding the damp proof course and how that is still achieving what it's meant to be achieving. Understanding the performance of the building as a whole, as is. So, you know, understanding the existing U value of the property, understanding the existing airtightness of the property, carrying out a SAP assessment on the property in order to make sure that you've got sort of as designed and as built will meet, and you've got that ability to judge how the building has improved with the works that you've been carried out to it, and ultimately the affordability of the measures required.
Fabulous, thank you very much. Pam, can I come to you with this one from YouTube from Amanda? The dynamic assessments look complex. Are they difficult to produce, and what information is needed for them?
I mean, certainly compared to a static state glazier calc, they are more complex to produce. Obviously, the complexity of that depends on the complexity of the building. One of the biggest challenges with the calculations like the hygroscopic WUFI calculations, the dynamic modelling, is where you've got historic buildings, you don't necessarily know what material that's made out of. You don't always know the sort of this specific heat capacity of the building materials, how much moisture they hold in. So a big part of it is making an educated assessment of the wall construction, trying to apply the most applicable products within. They've got like a wide range of stock material that's been assessed and added in. So trying to make sure that you're using a material that's applicable to your country, not necessarily something that might be used in North America that has different performance criteria. So it's knowing how to input the materials and the construction in the first place. It's knowing where you want to put the assessment and review points in it. So you can put different monitoring points throughout the full construction. It's knowing what air changes to allow, or doing variations of sort of like best case against worst case. So it's all of these things, and that's just to get the calculation to run. You need to know the orientation, you need to know the positioning of it, you need to know the height of the building. Ideally, you need to know what the external finish is, what the surrounding ground it is, because that can all have an influence on it as well. So these are all things that we kind of need to try and hone down on. Once we've got that, then you can you run the calculations, and then the fun bit starts, where you're trying to analyse the graphs and the information that is put out. So it's really very much a dialogue between ourselves and the people that are wanting us to look at the calculations, the developers or homeowners. So it is a very complex tool, and it lends itself, because of the complexity of analysing everything. Sometimes it's good to use static state glazier as a work in progress tool. So to work out what different types of insulation does, you can get an indicative idea of condensation risk with that. And then once you've kind of down to your final one or two options, that's the point where it can go into WUFI, rather than use WUFI as a design tool. It's an assessment tool in the final design, rather than a let's put everything in there and see what comes out.
Fabulous, thank you very much. Well, if I can come to this one on YouTube from Greg. I always understood that enveloping the building with insulation is the best way to go when upgrading thermally. But why would I choose IWI over EWI?
Greg, IWI versus EWI, which side do I want to upset the least? No, I think seriously, it's going to depend on, obviously, your project. Every project's going to be unique, and it's going to come with a unique set of challenges. I think most importantly, probably space. What have you got there around the building? Obviously, either inside the building or outside the building. What can and can't be done? We have lots of properties in the UK that need upgrading, that are on the road, like pavement-facing properties. You can't simply go and obviously EWI those, but that doesn't mean that we shouldn't upgrade those, and that's where IWI comes into its own. Not just that, you may be in a conservation area, so you may have restrictions there. You may have a facade that you just want to keep because you like the look of it. You know, we have some very, very attractive buildings out there that are quite decorative, that either don't want to be adjusted or changed at all. So EWI is obviously going to completely cover that in the way that it's installed. So that's kind of the main reasons why you'd go for an IWI over EWI. There's also probably cost and speed, depending on the type of property. If you've got the space to do it internally, you can pretty much do it any time of year. You haven't got to worry about the weather because it's going to be done, in the dry, hopefully. And obviously probably can significantly reduce cost as well because you're not having to replace that facade, whatever that facade might be. So yeah, it just totally depends on the project, and what's right for the obviously the owner, the occupier.
Yeah, perfect. I'm going to just jump to this one well past I've got you. This has actually come in an email, so it's quite a good one to follow, and I'll come back to the YouTube ones in a second. Steve from Leicester's emailed in, would it not be best to utilise the masonry in my wall as heat storage? I won't get this with an IWI system.
That's a very good point. It is. I mean, obviously, you can, again, could have sort of following on from the last question. You're right there, Carol. It's going to depend on what you have. If you have the space to go externally and you want to do that, then that's a very, very good option. You will get thermal mass from the solid masonry. However, looking at the negative side of that, if I may, although you might keep the building warmer for longer if you heat that masonry, it's going to take longer to heat up in the first place. So the initial heat load on your heating system is going to be much higher, because we've got to heat that mass first, obviously. If you're sort of in a property which is only being occupied at certain times of the day, therefore you've got your heating system set to come on at different times, maybe only once or maybe twice a day, you're having to wait for that building to warm up because you're heating the masonry. If we look at an IWI system, your sort of the speed, your warm-up period is much quicker. As soon as your heating is either turned on or turned up, you expect a much quicker reaction to that being done. So that's where IWI does come into its own. So for someone that is looking to heat a space of a property or the whole property quicker, that I'd say that's probably a better option for you to go for IWI there.
Perfect, thank you so much. Let me jump back to some of the ones on YouTube. Ian, can I bring you this one from Lauren? I always thought BS 5250 only dealt with the control of condensation.
Yeah, you're right, Lauren. BS 5250 used to deal with the control of condensation in buildings. However, recently, or in the recent times, the standard has been looked at again, and indeed, Pamela and myself worked on BS 5250 with me chairing the walls sections, which is quite challenging when we look at the subjects today, for example. So that revision of 5250 was in July 2021 published, and it now looks at the management of moisture in buildings rather than just condensation. Seemed to take a while for British standards to realise that sometimes in the UK it rains, and that can be a source of moisture within the building. And it's not just condensation that we should be considering. So it's more just like our HAM principles that we preach at Proctor's. It's more about the holistic approach to controlling moisture and managing moisture in buildings. So yeah, it has changed from the control of condensation to the management of moisture in buildings now.
Fabulous, thank you. James, can I come back to you with this one? This one's come in on LinkedIn from Ian in Scunthorpe. Is airtightness key to improving my home?
Improving the airtightness of your property is key, basically, to enhancing its energy efficiency. So the increased airtightness will reduce unplanned air movements or drafts and reduce heat loss through convection, therefore making the building more efficient. However, a firm understanding of how this improvement will affect the air exchanges within the property has to be taken into consideration, obviously before the works are carried out, in order to make sure that whether you need to utilise a passive or mechanical ventilation system, in order to make sure that the inhabitants stay healthy and happy.
Perfect, thank you so much. Pam, can I come to you with this one? Back to YouTube here from Sean. When it comes to breathable walls, gypsum plaster and most paint is not breathable. How does this affect vapour permeability of aerogel and Wraptherm?
Okay, yeah, so it's quite a good one. We get this one quite a lot. It's very difficult, as we sort of touched on earlier, to know what the performance is of historic products, and also things like the thickness of the gypsum plaster. So if you actually take like a lime skim and a multi-thistle coat, there's not a lot of difference in the vapor resistance, which obviously is a thin layer is less of an impact than there might be if you have a thick sort of solid, solid sort of inch thick plaster coating on your wall. Obviously, if you know you've got something like a old historic distemper, which were quite often used to like block out damp coming up and coming through the walls, if you've got like an oil-based or gloss type paint or paper or anything on there that you are pretty sure might be causing problems, and you could see that because you might have like spots of mold or cold areas, then it would probably be recommended to take that off, so that you're starting with a base wall. If that wall is working okay, and it's not like damp coming through, then adding things like aerogel or Wraptherm or the space therm laminates over the top of it shouldn't have too much of an impact, a negative impact on the overall permeability. Again, it's balancing the amount that you use compared to the walls. So it does need to be taken into consideration, but it's not, I don't think it's always as scary as some people think it is, unless you're doing like a really, really deep refurb.
Perfect, thank you. Pam, can I just stick with you here? Bill Simpson said, what is the makeup of ProTech Adapt and how does it work technically?
Good question. You might need to tag team me in this one. It's got some good analogies with the Adapt. Yeah, basically it's a polymer. So it's I'm not a chemist, unlike my father, but it is very much on the polymer reacts. So the way I try and get it straight in my head, it's a little bit like those gels that go into like plant pots for holding on to water to keep soil moist for longer. So when there's humidity and moisture, they sort of swell up and close. And then as the conditions are right for drying, so the temperature's warmer, there's less humidity in the air, they start to dry out and release the vapor and allow that, any moisture that might be in the wall to sort of like reverse drive or, create that more permeable situation throughout the wall. So that's how I kind of do it. I don't know the chemicals, that's probably a trade secret, but it is a polymer that reacts to the moisture that basically is in the air around it.
Fabulous.
I think if I could just, it's a great answer, Pam. I would agree with everything you've said there. Yeah, but there's a copolymer in the membrane, and just as Pam said, it's probably a trade secret as to how that actually works, that copolymer. But suffice to note that the example that Pam gives is a good one there. I tend to use the skin as an example as well. But just like the skin opens the pores if need be when it gets too hot, and then closes as necessary as well. That's effectively what the Adapt's trying to do there. So it's obviously an intelligent membrane, so it's very much the same as others in that field. However, the range of its breathability or vapor permeability can range from 0.14 to 90 meters. Also 0.14 being very breathable, 90 meters being almost vapor control levels. So depending on the environment, it'll open and close as you need it. So in the winter, it tends to be closed. In the summer, it opens up to allow the building to dry out. The sun also has an effect. So it's not just the internal environment. The sun will have an effect as well. So you get a degree of solar gains and stop that reverse condensation. So it's really quite a super membrane. for want of a better technical description of a super membrane. But it does do quite a lot in the construction that you want, and at the same time being airtight.
Yeah, perfect. Thanks, Ian. Now, Graham put another question on the YouTube feed. You might have covered most of that. How does ADAPT compare to other types of intelligent membranes? And what humidity levels trigger the change from vapour closed to vapour open? So I don't know if you or Pam want to add anything extra in on that one.
Yeah, I mean, I think it's a great follow-on question. It's almost an obvious question. As I said, the SD value goes from 0.14 meters. This is the European way of measuring vapor control and vapor permeability. So the lower the figure, the more breathable we would call it. So vapor permeable to the meters, the higher meter of 90 meters. And what you're trying to do there is compare the vapor resistance in meters, equivalent meters. So the lowest is more breathable, the highest. So when you get to the levels of 90 meters, that's really quite a lot, obviously, of vapor resistance, and you've got 90 meters. So in terms of how the ADAPT compares, that range is probably, if not the highest, it's one of the highest ranges to allow that membrane to transfer. So I think that answers the question.
Thank you very much. Well, let me just come back to you for this one. Peter's asked on YouTube, back to your EWI battling. Can you combine EWI on some elevations with IWI, or is this just too risky in the context of cold bridging at the junctions?
I like IWI and EWI, by the way. Just make sure everyone knows that. Okay, so I think we're looking at like a hybrid system here, if I'm not wrong, Peter. So first and foremost, we have to make sure that the main wall area is going to be suitable, that you're going to have to run that through a condensation risk analysis. And that's really finding a balance between your insulation layers. The more layers of insulation we add into an element such as a wall, the more risk we could potentially create. And especially when you're looking at foil-faced insulations and insulations that can potentially not allow for ease of vapor permeability through the system. So if we have a hybrid system where we have a layer of insulation on the inside of the main structure and within or on the outside of the structure, we would look to run a condensation risk analysis on that to see if there was to be any risk. And a simple rule, and I will say simple rule because it's not always the case, is you want the insulation on the colder side of the element to be the thicker or the better performing product. And that would mean that your condensation risk is actually pushed further out. Your dew point is pushed further out through the wall in a typical sort of British climate. And we would expect there to be obviously less risk, and any risk that is occurring is happening in the right places. When it comes to junctions, this is a really tricky one because and it's kind of, this was covered a little bit in the webinar earlier. We do have to be really careful. As soon as we introduce insulation into a system, we create a risk. I think that's regardless of whether you've got a hybrid system or not. The most important thing is where we have those junctions is how we actually detail and insulate those as well. Do we have the ability to go around the junction if it's on the inside? Do we have the ability to go into a window reveal, for example? Simply leaving that junction uninsulated is what's going to cause the most risk. Certainly, if we are insulating to the outer side of the structure, we can normally cover this off quite well. But we would obviously look at junctions on a project by project basis to see where the risk would be, and hand in hand with a condensation risk analysis, a U value calculation, and potentially psi value calculations as well. We'd look to try and make sure that the risk is minimalised in these areas. I hope that answered that question.
Perfect, thank you so much. Ian, let me jump back to you here. I've got an email that's come in from Riza in Cork. Can insulation be injected into the cavity behind the lath and plaster?
Yeah, it's a question that we're asked quite a lot. In an ideal world, we would love to inject insulation in that lath and plaster void, because injecting into cavity walls have been so successful in the past. So the obvious thing would be, well, why can't we just put it in the lath and plaster? Unfortunately, it's not that obvious, because what you're looking at when you're getting inside the building is you're looking for vapor permeability, or as most people would know, breathability. So you're looking for breathability of that insulation once it's put in. Now, interestingly, we were involved in European research in this area, where we were contacted to be part of it. There was 21 partners from 18 countries looking at this issue of how to improve the energy efficiency of historical buildings, which probably adds to the question or point that Peter made earlier. So how do you actually improve insulation of these types of historical buildings that you can't do anything on the outside, and you really don't want to do anything on the inside? There isn't a cavity. So how can you improve the energy efficiency? Now, one of the ways in these older buildings is that they've got lath and plaster. So you can actually insulate on the internal side in that cavity of behind the lath and plaster. So our task, along with other partners, Proctors were given the lead role for improving the energy efficiency there. And it was thought, well, space therm would be the obvious choice. And it would be, but in its current format and roll format, it's very difficult to put in while still keeping the internal lath and plaster. So we worked on how to inject it into that cavity. And what we found was we had to chop it up into little cubes, 10 millimeters insulation, make it into 10 millimeter cubes, or even smaller if we can. And that was to stop the long fibers that you get in space there, make it into small fibers so that when you did put it through the internal machinery for injecting, it didn't tangle. And when you injected it behind the lath and plaster, it didn't tangle as well. So we managed to do that. We got it tested, lost a little bit of its thermal benefit, but not massive. We managed to keep its vapor permeability. It was tested for fire and did well on fire as well. So it was given a robust lots of testing. We were very pleased with it. When we installed it, we got local installers, BCA, to install it and doing a trial. And they installed it and they found it, in their opinion, the best insulation for filling a cavity. So all great, but like a lot of research, once you've got all the answers together, the technical people can be guilty of this. So hands up, probably me and Pam for this one. We had a great technical solution, but when we put it to the commercial guys, we couldn't make it commercially viable. Even though it was a great result, the price of actually manufacturing that into the little cubes was so difficult that it became commercially unviable. So watch this space. If we can get somebody with a big chopper to make the space therm into cubes easier, then we have a solution, but not at the moment. So yeah, you can inject into that cavity. It could be expensive if you want to use space therm, but you have to monitor its vapor permeability of anything you put in that cavity.
Perfect. Thank you so much, Ian.
Long-winded.
Always an education. James, can I come to you with this one, please? This is from Liz in Glasgow on email. Can removing the existing gas-fed heating system improve my home?
In a word, yes. I mean, obviously, from what's going on in the world at the moment in regards to sustainability, in regards to reducing down the carbon footprint, anything you can do in order to assist in regards to becoming more sustainable, especially from a home point of view, is great. But ultimately, the energy efficiency of the property, which is the main reason why we do these. So by upgrading to a more efficient heating system, such as a heat pump or a geothermal pump, then you can reduce down your energy consumption and therefore lower your utility bill. Depending upon the gas heating system used, indoor air quality can be enhanced by removing the risk of byproducts such as carbon monoxide and nitrogen dioxide. But again, just like before, what I'd stipulate is before making changes, please consult an HVAC engineer or qualified contractor who can assess your specific needs and evaluate the feasibility and provide recommendations based on your property's needs and indeed yours. Again, we have a case study on the website. So if you'd like to have a look at that, get in contact and we can hopefully alleviate a few areas of concern in regards to that.
Perfect. Thank you so much. Pam, let me come back to you. I've got one here that's coming from Joanna on LinkedIn. I've taken on a derelict property which has been poorly maintained and has a lot of water in it. What do I need to watch for and how can I make sure I don't build in issues?
Yeah, so we've had a few projects like this over the years where maybe it's been badly fire damaged, soaked from that, left without a roof or doors and windows. So one of the big things is making sure that you try and get that drying out process started as soon as possible. So, get it wind and watertight, take off any areas that are, really sodden, like if you've got really damaged plaster, etc. here as well, to take that off and start again. Let the building start to settle, dry out and reach equilibrium. So you can put in things like dehumidifiers and space heaters and things like that. Just watch some of the space heaters, because if they're gas, they'll be contributing more moisture as a byproduct to your building. Another one is important, excuse me, before you start looking at any internal or external insulation for that matter, is making sure that things like your downpipes and your guttering and flashings and pointing, all of these things that are actually mentioned as watch points in 5250 now, are all looked at and considered. And then look at, what type of insulation you want. Things like the space therm, like permeable solutions, even Wraptite, if your walls are still good, Wraptherm internally. That will help to allow the building to continue to dry out. And this is actually where, going back to the roofy, the dynamic modelling, it can be really useful. So we can actually build in a large amount of moisture. We can run it and see how long it takes for that wall to reach equilibrium. We can even sort of like run it as a base wall, see how long it's going to take to sort of dry out to a point where it's sort of safe to go on. But it's, watching things like the ends of your timbers as well, that you're not sort of building them in really, really wet. Sort of allow the building to kind of settle a little bit, and then you can get on with the important part of insulating it, using the right insulation to allow the building to continue that drying out to reach that equilibrium over time.
I think we're all going to need some severe drying out up here. We've got torrential rain again up this way and no doubt lots of flooding. Not fun. Ian, can I come to you? I've got an email from Zoe in Inverness. You mentioned a conventional AVCL can cause more moisture issues. Can you give me some more examples?
Yeah, good question, Zoe. Yeah, we mentioned conventional AVCLs in the presentation. To use a common phrase, it depends. Depends on lots of different variety of matters that you need to take into consideration. So I'll give you an example. My son and his fiance have a cottage which is very cold, and my son came and asked me quite a lot of times at the weekends, what can we do to insulate? What about this? Can I do this? They're sleeping with electric blankets on, which is not great for a new couple. So we went to have a look at his house. It's a stone-built house, cottage, lath and plaster. The walls were sound. They were just very cold. We took off the lath and plaster and kept the frame, the 20mm frame, and then we put in 20mm, 2 layers of 10mm space there in between the 20mm frame. Once that was put on, we then used an airtight vapour-permeable membrane over the top of that, and then we used extruded polystyrene 10mm to show where the studs were, so that we could put the plasterboard on top of that. Now, I don't have my son coming around asking about his cold house. He's very cosy, and that has worked very well. So the airtight layer, albeit not the self-adhered Wraptite one, still worked to stop the drafts. The 20mm insulation kept the heat in and stopped the cold coming in as well. So that was a great example of how you could refurbish a stone house to acceptable levels. It wasn't necessarily building regulations, but because it was a refurb, it improved the comfort of that house dramatically, just in 20mm.
Perfect. Thank you so much, Ian. Pam, let me just jump quickly to you. You'll be able to answer this one for Bill on YouTube. Is there a cost for proctors to carry out the WIFI calculation?
Okay, yeah, so we use the WIFI analysis as a tool for the specification and the sales of our materials. So if our materials are being used deemed appropriate for it, then there wouldn't be a cost for it. We don't provide a consultancy, so we wouldn't sort of like do your designs, but there are other companies out there that will do that, but they will charge. You know, we'll be able to provide advice whether WIFI is applicable or suitable. They do take a bit longer to do than other calculations, but it can be discussed. But yeah, where our products are being used, there's not usually a charge.
Perfect. Okay. Well, let me jump to you here. I've got one from Shane in Coal Island who says, I've seen on your website that I can direct fix your space therm product to the wall. Do I not need a batten system? Oh, think something.
Sorry,
Oh.
I mute myself there. Sorry. Okay, so it's quite common to see a batten system in IWI. So that might be the concern there. It's normally like a 25mm treated vertical timber at sort of 600 centers or something, and that helps to move the insulation away from the masonry wall internally, which can help reduce any sort of condensation being trapped between the two products. It also acts as a service void as well, which people might want to introduce. It's quite handy to have that there hidden away. I'd certainly say it's not a problem with the likes of a product like Space Therm. It's more flexible. When it's installed up to a solid wall, it sort of won't leave any sort of air gaps, which could potentially allow moisture to sort of build up as condensation. But also it's a hydrophobic product, so it'll naturally repel any moisture away from it. So you can install the insulation directly to your solid wall without the need for the batten system at all. The likes of the Space Therm Multi, which has a 6mm MgO, is great for saving space. So that's the insulation bonded to a magnesium oxide board. But we also have the likes of the Space Therm Direct Fix, which not only has a 12.5mm plasterboard bonded to it, but within the plasterboard, between the plasterboard and the insulation, you have a 6mm ply, and that's really good for a more robust solution for fixing directly to your solid masonry. If you're looking to still introduce that service cavity I mentioned earlier, you could potentially still fix Space Therm direct to the solid masonry wall, and look to introduce your batten system sort of in front of that. So sort of before you see your plasterboard being installed, sort of more traditional. This does also allow us to introduce, mentioned before, the ProCheck Adapt product as well. You could introduce a VCL between your plasterboard and your batten cavity. So just to sort of go through that internal to external, you'd have your plasterboard, internal finish, skin, whatever that might be. Then we could have a VCL such as ProCheck Adapt. You'd have a 25mm batten system. Then you'd have your insulation, like your space therm, and then your solid masonry. So in answer to that question, long-winded way around about it, no, you can fix directly to the masonry without having to have that batten system directly behind the insulation.
Perfect, thank you, Will. Pam, can I come to you with this one? Another email from Brian. You mentioned ProCheck Adapt and Wraptite. Which is more applicable for use in an upgrade to EnerFit standards?
To paraphrase Ian again, it depends. It depends on what type of wall construction you've got, what type of insulation you're looking at using. Products like the ProCheck Adapt, really to get the performance out of it and the benefit of that intelligent nature, you do need to use it with a permeable insulation. So that would be something like maybe a wood fibre, mineral wool, sheep's wool, that sort of permeable, breathable type of insulation. But then that also fits very nicely within the EnerFit and passive house type philosophy anyway. If you're using more rigid insulations, then actually Wraptite might be suitable. It might be the combination of both of them. A lot depending on the amount that you use and where you place it. Obviously, EnerFit is not as onerous as, for example, a new build passive house, but they're still both relatively safe. So the simple answer is a lot depends on what you're planning to do, what level you're going to, but both products, it's worth noting, are certified by the Passive House Institute. So they're both products that should be accepted relatively easily as products for suitability within those certified projects.
Fabulous, thank you very much. Ian, I'm going to come to you. I'm jumping back. I haven't missed this one. I've just had so many coming in on email. Alan has said on YouTube, invariably solid walls have no DPC. How important is forming a DPC before insulating?
Yeah, I think that is an important factor. If we go back to my son and fiance's house, luckily that had a DPC injected into it, which is relatively unusual for a building of that age. It was only when we cut back the ivy that was all over the house that we actually realised that it had been treated with a DPC. But I think it is important to look at the DPC level because you are now changing the cottage or house, building, whatever, its hygrothermal properties if you're going to insulate and improve its airtightness and do other remedial measures like double glazing. So the DPC shouldn't be forgotten about, and it is important to do that. And it's a good time to do it at the same time as before you do the insulation. Make sure that you're stopping the damp or reducing the amount of damp getting into that building in the first place. So great question, Alan, and hopefully I've answered that adequately for you.
Perfect, thank you very much. Now I've actually only got another couple of questions here, so if anybody still has something they would like to ask, please just quickly drop it into the YouTube chat feed now, or you can drop us a quick email, or like I've said earlier, we can come back to you if we don't get to you or you don't get it through to us in time. Pam, can I come to you with this one? The ESSA Trust have said on YouTube, if you do not have the budget for modelling, as well as all the other costs, but have to combine IWI and EWI, where would you say are the best details for junctions?
Good question. I'm not sure I have the absolute answer. Obviously, speaking to the suppliers and the manufacturers of those products to see whether they've got anything specific. I know the Scottish Building Regs had a lot of really good sort of accredited details or sort of like assessed details for coal bridging, so they can be quite useful. even things like if you're going between an internal and external, so say for example, if you had like a front facade onto a street that you had to do internal insulation, yet down the side and the back you could go with your external insulation, then even taking a layer sort of like 500 millimeters to a meter internally around the corner, if that makes sense, that will help to reduce the thermal bridging. So it's sort of a simple rule of thumb is if you carry that insulation beyond to about a meter beyond that junction. So for example, if you had like a T coming in, if you insulate along that internal wall at 1 meter, you're going to be mitigating any sort of heat flux from an uninsulated external, that sort of thing. So that would be something to consider. It's really just sort of trying to junction it as well as you can, so that you don't have like suddenly going from really warm to really cold, because then you could get cold bridging. I don't know if anybody else knows of any other sites for good detailing.
I would say, Pam, you've dealt with that very well. The 500 to the meter inside is deemed to be good practice. I've always struggled with it, to think that you could have an internal wall that's a meter insulated to stop the cold bridge, and then it has a step for the maybe perhaps next 2 meters. So I think you're right, and you are right that the meter is generally the rule of thumb for stopping that cold bridge.
It's actually quite a good point where the things like our space therm can be useful. So even like a sort of a cold bridging reduction, you could get quite a thin solution with either the wall liner or even the multi, which can allow you to sort of taper off that end so it's not so glaringly obvious a step, or either that or just own it and turn it into a decorative feature in your building.
I mean, it's well worth saying that obviously we've done quite a few of the refurbishment projects with various products that we manufacture. So it's, we've probably got the knowledge within the company already. So depending upon what details, what junctions you're dealing with, then we may already have the answer for you. In regards to sort of cost modeling, that side of things, obviously, as Pam stated earlier, that the hygrothermal assessment is subsidized, as I like to call it, as opposed to free. But it's there to be utilized. It's there to be understood. We can take you through those analyses as well in order to make sure that you fully understand them. So if you need to explain them to building control, if you want to go in with us, if you want us to come in with you with building control, then obviously that's not an issue either. We can speak to them with you on your behalf in order to explain the analysis to them. But again, I mean, junction details, if there are drawings that have been put together, even on the back of a fag packet, then as long as we've got the full understanding of that junction, of that detail, then we can obviously advise from there on how to best negate that cold bridge through any axis. So please just get in touch in regards to the projects that you're working on, and we'll be more than happy to help.
Absolutely. Thank you very much, everyone. Ian, I'll just jump back to you. Alan has just commented after the DPC question. He says, I wonder how effective you consider injection DPCs.
Thanks, Alan. I'm going to use Pam's word, depends. I think the example I gave earlier about the injection being done in my son and fiance's house, it's there. It's obviously injected, so it's drilled every 6 inches, and then you inject the resin in there. And the reason I've said depends, because it really depends on how porous the stonework is, because you're only doing every 150 mil, and you're expecting a degree of transfer of that injection to bridge that 150 mil or 75 mil both ways. So yeah, it's not as ideal as having a DPC, but it's certainly a lot easier than taking off all the walls, putting down the DPC and replacing. So how effective it can be, I think it's a good thing to have. Anything's better than nothing compared to where we were. But it would depend on how well it's done. It can, I think there's potential for people to fool the house owner that it's been done effectively. So you'd always have to be careful of that. But it can be done well, but not necessarily always.
Depends.
Depends.
Perhaps we need to have a case study for the next one and have special guest stars from Scott and Emma to help us out with the next one.
That's a good idea.
Right, this is, I think it's my last question. Hopefully I've been through everybody, I've double checked, and I think this is the last one. Pam, if I can bring this to you, this has come in on email there from Tony, who says, what are the pros and cons of Wraptite versus in an internal parge coat?
Okay, yeah, we get asked this sometimes because a lot of people are starting to look at using Wraptite as an alternative to a parge coat because it can be quite expensive. There's a lot of moisture that you're introducing there. You obviously need quite specialist skills for a parge coat, whereas, you know, even sort of people like me can install Wraptite. A lot will depend, again, I'm sorry using that word, but that's the nature of the construction industry, isn't it? Some substrates lend itself really well to using Wraptite internally. So like the image in our sort of like headline we talked about today, Wraptite on your internal plaster or smooth surface, plasterboard, etc., to add that airtightness line is absolutely fantastic, really easy to install. If you're looking at using that as the base layer on, say, an existing externally historically rendered building to provide your airtightness line, that surface is very rough. There's possibly contaminants on there from environmental factors over years, which could make getting the Wraptite to bond harder. So smoother surface, the more area, the easier it is to bond. The rougher the surface, the less surface area there is for the adhesive to take to. Often it's harder, then you might need things like primers, etc., to just help that, or even you've got the added risk of puncturing the membrane. You know, if the surface is really rough, that could puncture and damage your airtightness line. So in some situations, also depending on how internal lines are coming in, as much as it pains us to say Wraptite isn't the answer, sometimes a parge coat may be the only solution that is viable, depending on the parameters. But as I say, it very much is dependent on what you've got, what type of brickwork, blockwork, wall surface is there. You know, give us a shout and discuss individual projects with us so we can help assess and point you in the right direction.
Perfect. Thank you, Pam. I think that's covered all the questions for today. If I have missed any, I'm sort of quickly searching back. I think we've covered everybody. If there's anything I've missed, I do apologise. We will get back in touch if we've missed anything. So some great engagement for you all, which is what we really do enjoy, and that's why we're here. If there's anything at all that you would still like to ask, or you do have a project that you would benefit from a discussion with one of the team, please do get back in touch and we will get back to you straight away. Do subscribe to our members area. Like I said earlier, there's a whole lot of information and resources in there that you can use, as well as looking at all our previous webinars. Please subscribe to the YouTube channel, give us the thumbs up and leave some feedback. We do look at all the feedback and we take it on board. It helps to shape future content. Registration will be open shortly for our next webinar taking place 24th of November at 10 AM, and we certainly look forward to you joining us again. All that's left for me to say is thank you, as always, for taking the time out of your busy schedule to join us this morning. And of course, thank you to all my lovely panel with me today and the fantastic team behind the scenes who put this all together on the day. So from all of us here, do have a great Friday, enjoy the rest of your weekend and take care. Goodbye.